Welcome to our next session, which is Bill Burdick. Bill is an engineer at Julia Hub, and he will tell us about how to debug 1,000 programs at once. Over to you, Bill.
Hey, okay, so this is the block diagram. That's a little noisy, but hopefully it'll be better. So, as Avik said, I work at Julia Hub. I do some fun open source projects. My handle on GitHub is Zot. This is part of a little organization on GitHub that I made called Leisure Tools that I've been working on since 2011, I think. This part is very much a work in progress. It's not quite ready for public use, but the goal is to get there very soon. So one reason for the talk is to gauge interest, to see if anyone is interested in this stuff. It lives in the Leisure Tools GitHub organization. The two main repositories are Monitor.jl, which is the Julia part, and Leisure Command, which is a Go program that integrates a whole bunch of Go projects. The motivation is debugging remote Julia programs is difficult. Large numbers of jobs is even harder and time-consuming because, analyze logs, change code, log more information, redeploy, wait, go to A. Dynamically changing logging as jobs run would be a lot better. And targeting and interacting with problematic jobs as they run would be even better. So I'm going to show a couple demos of this stuff. Is this? Yeah, it's visible. Okay. So the first one. Okay, so this shows a basic, as Julia starts up, it's going to populate this with another block of JSON, YAML. I'm showing it. So the idea of this is the root. This block has 3 properties in it, and they're tied to variables off of the main.engine object in Julia. And I have a rename here so that when a program hooks up to this, it'll send its own block it'll publish a block, but with its own name so that it is namespaced, so that you can get blocks from a bunch of different programs in here and they're not all going to try to overwrite the same one. So if I change this. You can see that it changes to 3 right here as soon as I set it to 3, and I can change it. And then also, I can change values in the document here, and then send them through, and you can see it changed right there. So if I So that's like a kind of a basic idea of what this, what you can do. You can monitor values in Julia in a bunch of different, potentially hook up with a bunch of different programs. And I'll go over how this all hooks up in just a sec. I wanted to also show, oops. Another one that's a little more complicated. Well, actually, let me show the basic. Okay, so this is the basic document. I'm going to show this before I actually run it. So the idea is we're still monitoring like an engine, but we've got this special property in there that actually runs a method in Julia, check temperature, and we're going to define that method in the document here. Here's the check temperature method, and it just basically says if the temperature is 2600 or higher, then we're going to create a new monitoring block and publish it, right? So when this starts out, it's not, this block here, which is marked quiet, is just going to be dead. It's not going to actually do anything, but it will install a monitor in Julia that's actually running, but it's not publishing any results. So oops. I'm just going to wait for it to warm up here. So it printed defining check temperature because I have this code block that runs code in the Julia programs that receive it. And now if I set temperature to 3000, it's going to publish the block here, the monitoring block on that engine. And this is because of this check temperature method that was automatically running. And so you can see it's 300 here, or 3000 here, so if I just change it to 3001, it updates right here. Okay, so this is a basic, and I realize I didn't provide a huge amount of context for this, but this is just the basic flow. I just have a feeling that I have too many slides, so I'm kind of trying to plow through. So in the first basic engine, the basic example I gave, I showed that each peer has its own namespace, and blocks can target different topics, which you can see in this block here. We've got the engine here is tagged with the peer ID, and then the block targets this particular peer so that other peers aren't going to respond to this monitor. And the next one was just like how you find and interact with bad engines. So there's custom diagnostic code that Monitor.jl injected from the document I was using to drive this thing. So here's the block diagram again, and we can focus on, blocks flow between programs. So the idea is, like, what if Julia programs could receive and respond to commands like a botnet, but not for denial of service attacks, but for diagnostics. So the idea is you can publish and subscribe with multiple topics. You can have read-only behavior if you want. You can have write-only behavior. You can have targeted commands and data like I just showed. And you can have a monitoring facility that reports and changes Julia values. Currently, this uses REDIS for publish and subscribe. It uses REDIS streams, not REDIS pubsub, because REDIS pubsub is not reliable. It's just best effort, but streams are reliable. Streams also will stay around forever if you're not careful, so one of the things this does is like trims the streams. You could use other reliable pub subsystems like libp2p, which powers IPFS, or and something like MQ. Pluggable, the transports are all pluggable. The second half of the block diagram shows communication going on between Julia and the JSON data, the pubsub data. So this is kind of sort of a new but existing UI approach, because it's something that I was using at another company that I made like 2006, I think, but we never publicized how it worked. And it's similar to some modern UI approaches. So it's been in use for about 20 years. Uses two-way binding for variable objects to bind those variables to paths within Julia. And some people say two-way binding is bad, but if you do it right, you can power a platform for 20 years with it. binding variable objects is a common UI pattern these days. Packages like Vue.js use it, and you see observables.js or .jl uses something like this, or can use it. So Monitor.jl implements this in Julia, and it's fundamentally front-end agnostic, because if you model, if your UI just reflects your state, you can build an abstract like presentation layer in data in Julia that doesn't actually know whether it's, whether a progress bar is tied to a progress bar in a browser page, or whether it's tied to a dwarf digging a hole in a medieval village. It's however you want to represent these things is you can change it. So you can hook it up to a terminal UI like I was just showing. You can hook it up to a desktop UI browser. I once demoed it, hooking it up to Quake. And like, how is this new? It's different from observer pattern mechanisms. I don't use the observer pattern like in observables.jl. The observer pattern comes from Smalltalk, a mechanism called change update, and the idea is that when you change a variable, it informs the system that there was a change, and I don't do that. So instead, I use polling, which seems like it could be slow, but because I'm using polling, the system doesn't need to be informed whenever something changes, because the polling mechanism can tell that. It's actually very fast because it doesn't do much work. Our app at my old company had 12,000 or more active variables at once for a map-based interface where like every map square was had X, Y, and the image URL and all that stuff, and like there were a lot of variables, and it was very fast. Getting a reachable value doesn't require any modification of your code, provided that value is reachable. Observed code doesn't normally need to include Monitor.jl or even know about it. There are a few caveats that I'll talk about. Another project, Leisure, uses this type of a UI system in the browser, and it combines handlebars, templates with JSON data, and that fully drives the UI. The whole thing's templated and based on JSON data, even the outer shell of the, Leisure's like a notebook system. So, idea is that, if you actually want to build a UI with something like this, you could make one peer handle the UI and then help you manage state for all the other 1,000 things that you want to monitor. There's a next-gen Leisure that's in the works, but it's not ready for me to demo, unfortunately, but I'm going to show a tiny demo of old Leisure. So old Leisure had, so this is a little cramped. Maybe I can zoom out here. So here is some YAML data, and I can change the value of it, and you can see these views update automatically here. And the views themselves are defined here in the document itself, and and so the entire thing is reactive, and so these so you can see, like, if I change this here, it changes the height. So you can do something like that, and this entire document here is defined with a big template that is based on JSON data and paths and stuff. So you can do some pretty elaborate UIs with just templates and YAML data, or JSON data. It doesn't care. It supports TOML too for people who hate YAML. Scaling, REDIS is already highly scalable, and MQ and libp2p are also, but you could generate a lot of spam with this if you publish a monitoring block, and then suddenly you get 1,000 more blocks that just suddenly appear in your document and are updating. So there are ways you can limit which peers emit monitor updates. So like I showed earlier, you can have you can trigger publishing a monitoring block if you want. You can publish to other topics that maybe the document doesn't look at. You can have a reducer peer that listens to like heavy topics and summarizes them, and then publishes to like kind of a dashboard summary. And it could, the reducer peer could publish monitor blocks on any aberrant peers that are causing problems. Some caveats. Sometimes values need to be made accessible because you might want to go through a global or something to get to them in the path. You have to have a way to get to your values. That's something that could require a change to your code in order to support monitoring. Even though it doesn't know about Monitor.jl, it's still, you might have to like provide probes into your code. Safe access to thread modified values can require extra steps, so there's some simple patterns for doing these things, but not all the, hopefully you wouldn't have to adapt your program to deal with this, but I mean, I think, if you're suffering from the edit, compile, deploy, log analysis cycle, I think it might be worth it to restructure concurrency a little bit if it can help with monitoring. So applications for this are diagnostics, also just general user interface, and even messaging between Julia programs. So if you got 5,000 programs, you could use this actually to communicate between them. Something I didn't cover is that there are 4 different types of blocks. Data block that just holds data, which can be useful for summaries and stuff. And then there's just a delete block that deletes old stuff. Future directions. I didn't talk about this, but there was a rename property at the very beginning that let's see, in my basic one. So I have this rename property here that says to use name. So it uses the name variable in main engine to name the block, so that when the block, when this monitor updates, it'll actually produce a new block with that name. So it might be nice to have like a template for that instead of just hard-coded like append the peer ID to the name. I'm planning to use this as a dev tool in Julia Hub as like in our private development stuff that for the platform team. And I need to test this at scale. I'm optimistic about that because I know REDIS is very scalable. Yeah, so that's what I have to present. I know I talked really fast, but I was worried I wouldn't get through it. So does anyone have any questions?
Do I understand correctly that this only captures the current state of the program? And if yes, could it be extended by exposing an OpenTelemetry or Prometheus metrics endpoint so that those current states get collected every couple of seconds and passed on to some collector later and displayed like in a span of time?
So it publishes, when you have a monitor block, it publishes a new value every time, a new block every time anything that it's monitoring actually changes. So right now it doesn't publish duplicate blocks. So there's not any kind of like you could make a heartbeat block with just a counter in it to do, and that's all just published to Redis stream. So telemetry could easily tap into that. Anyone else?
It's kind of continuation of the previous question. How you deal with the frequently changed values?
Every monitoring block can have its own update period if you want. The default is 1/4 of a second because I've found that's what humans deal with pretty well. But if you want, you can increase the polling value for a particular block for a monitor. Other than that, I mean, if values are, if they're changing really, really frequently, like hundreds of times a second, I don't think you'd want to publish hundreds of messages to REDIS every second. So what you might want to do is probably gather up some information and batch it, maybe something like that. So you could do that. The monitoring code is pretty flexible, and so you could actually probably even extend it inside of your, like in your control document in a code block and stuff. So I think you might even be able to do it without actually, maybe without actually modifying the code you're monitoring.
Any more questions? Well, thank William for a wonderful presentation. And I think at 12 there's also an ASML meetup or lunch and stuff with you guys. Okay.